Sakthidevi, Lecturer, Department of Electronics, Sita Lakshmi Ramasamy College, Trichy 2. Now we discuss the topic General Purpose and Special Purpose Diodes. What is diode? Diode is an electronic component and it is made up of PN junction. PN junction is made up of silicon or germanium semiconductor material. This PN junction is known as semiconductor diode, crystal diode or PN junction diode. This PN junction diode is known as general purpose diode because this diode is mainly used for rectification and switching purposes. So this diode is called general purpose diode. The structure and symbol of the PN junction diode is shown in figure. The anode lead is taken from the P-type material and cathode lead is taken from the N-type material. Working of PN junction diode. For proper working of PN junction diode, we give external DC source to diode. This is called biasing. There are two types of biasing. First one is forward biasing and next one is the reverse biasing. What is forward biasing? The positive terminal of the DC supply is connected to P-type region and negative terminal of the DC supply is connected to N-type region. This type of biasing is called forward biasing. The forward biased diode is shown in figure. Now we increase the supply voltage from 0 at a particular voltage, that is the cut-in voltage. The width of the depletion region is completely eliminated. Now the junction offers low resistance, so current flow through the diode due to the majority charge carriers. The magnitude of the current depends upon the applied forward voltage. What is reverse biasing? The positive terminal of the battery is connected to N region and negative terminal is connected to P region. This type of biasing is called reverse biasing. Now we increase the supply voltage from 0. The width of the depletion region is increased and the junction offers very high resistance. So no current flow through the diode. Only due to minority charge carriers, a very small amount of current is flowing through the diode, but this current is negligible. Applications of general purpose diode: switch, rectifier, clipper and clamper. Diode acts as a switch. When we forward bias the diode, current flow through the diode. Now the diode is act like a closed switch. When we reverse bias the diode does not conduct. It is similar to open switch. Now diode is used as a rectifier. Rectifier means convert AC voltage into pulsating DC voltage. Here we saw the half-wave rectifier circuit. In half-wave rectifier circuit, the diode conducts during the positive half cycle of the secondary voltage, so we get the output in load. During the negative half cycle of the secondary voltage, the diode does not conduct and we didn't get the output. So this rectifier is called half-wave rectifier. Diode is also used as clipper and clamper circuits. Clipper circuits are used to restrict the amplitude of the input signal. Special purpose diodes. A number of specific type of diodes are manufactured for specific applications. So these diodes are called special purpose diodes. Some of the more common special purpose diodes are xenodiode, light emitting diode, photodiode, tunnel diode, varactor diode and laser diode. Xenodiode. Xenodiode is designed to operate in the reverse breakdown voltage. At breakdown voltage, Zener gives the constant output voltage. This breakdown voltage is reduced due to the heavily doping. In reverse breakdown voltage, Zener gives the constant output voltage and diode current is increased. So, xenodiode is used as a voltage regulator. The symbol of the xenodiode is shown in figure. In the graph, from the graph, we see after the breakdown voltage, Zener gives the constant output voltage. Next one is the light emitting diode. Light emitting diode is used to emit the light when it is forward biased. This diode is made from gallium, phosphorus and arsenic materials. LED is also called optical semiconductor device, and this is used to convert electrical energy into light energy. The materials used for constructing LED determines its color. Different materials emit different colors of light. For example, gallium arsenide LEDs emit red light and gallium phosphide LEDs emit green light. LED gives visible light when it is forward biased. The various colors of LEDs are shown in figure. Next one is the tunnel diode. Tunnel diode is a semiconductor diode. It is used for switching purposes. A conventional diode exhibits positive resistance when it is forward or reverse biased, but tunnel diode exhibits negative resistance due to the heavily doped impurities. Negative resistance means current decreases when the voltage is increased. Compared to conventional diode, tunnel diode is 1000 times heavily doped. The symbol of the tunnel diode is shown in figure. Applications of tunnel diode. Tunnel diodes are used in oscillators, amplifiers and digital systems, used in microwave circuits and envelope detector. Next one is the varactor diode. Varactor diode acts as a variable capacitor. This diode is specially constructed to have high capacitance under reverse biasing. Capacitance value is in the order of picofarad. Capacitance value is varied by changing the reverse voltage. This diode is also known as varicap, voltcap or tuning diode. The symbol of the varactor diode is shown in figure. Applications of varactor diode. Used to replace variable capacitors, used to store charges, for tuning the circuit, commonly used in TV as electronic tuners. Laser diode. Laser diode emits a coherent beam of light. Wavelength of the emitted beam depends upon the choice of the semiconductor material. Today's laser diode range from infrared to ultraviolet spectrum. The symbol of the laser diode is shown in figure. Applications of laser diode. Act as a light source in glass fiber transmission system, used in barcode scanners, laser printers, optical computer mouse. A very high laser diodes are used in material processing, and laser diodes are used in scientific applications also. For example, spectroscopy. Thank you for your listening.